Hi there. It's time for a video where I do the sound activity for your viewing pleasure. Just a reminder, I am a lovely, real human being sitting here at his computer. I'm in my living room right now, just for excitement value. And just as per usual, I'm going to literally go to the web page with the activity and go step by step and talk about what I'm thinking and why I'm doing things the way that I'm doing them. Obviously, I have inside knowledge because I wrote the activity in the first place. But nonetheless, hopefully this will be edifying. So, sound activity. Let's begin. I'll begin over here on the sound activity page, which has the actual step-by-step instructions to follow. And off we go, right? So what are the objectives of this activity? Well, we've been looking at the P5 sound library, so I want to use a couple of those things, and I want to combine them with the kind of physics-based movement that we've played around with for a lot of the videos, building up this idea of kind of physics-based simulations. So we're going to use oscillators to add a particular sound to the movement of objects, circles, just spoiler alert, and also a synthesizer to add sounds when things bounce. Those are the two things that we're going to do. This is not going to be the most complicated activity that we've ever done. You know, sometimes it's nice just to do something relatively simple that hopefully is still satisfying. So the core idea is we're going to make a simple musical toy, which I think is a fun project. So what will we do? We'll have a blank canvas, and then when the user clicks, a moving circle will appear where they clicked, moving in a random direction. As it moves, it's going to be emitting a tone using an oscillator based on, the frequency of that is going to be based on its distance from the center of the canvas. So as it moves around, the frequency of the tone is going to shift. And also when the circle touches the edges of the canvas, it's going to bounce and play a note when it does so. And that note will come from a scale, so it should sound kind of musical as we add more circles. So we'll see. We'll see how it actually turns out, but I'm optimistic. So, step one. Create a new project. The usual, download a template project by clicking on it like I just did, or whatever you do. Unzip it, again, like I just did, or however you do it, and then transport it into your, holy crap, that's a lot of stuff. Transport it into your activities folder in your repository, and rename it to something like sound activity. That's what I'm going to call it. It's not a very, maybe I should call it musical toy. I don't know why I'm giving these things such uninventive names. Musical toy is what it is called. And then we obviously want to open that up in Atom. I'm going to do that here. Waiting, and there we go. I'm also just going to quietly close another window that I had open. So here we are. Here's my project. I'm going to write musical toy as my project name here. A program that plays music based on primitive physics. That's basically what this does. I could write a better description, but I have not done so. Okay, so I've taken these steps. Oh, and then obviously the next important step is commit in GitHub Desktop. I've got a few other things that I should have committed earlier when I was working on other stuff. So I'm going to say, I feel bad, giant commit of sound experiments and activity. Commit, push, done. Done? Done. Okay. So that's the sort of the initial thing out of the way. You already know how to do that. So, make a plan. Here is a suggested plan. Simple one today. We are going to make a class called ball that's going to deal with the idea of these balls that can move around on the screen and bounce. Then we're going to integrate them into the main script by having that ability to kind of click to add them. And then once that's all set up and we've got the basic kind of very simple physics simulation in place, we're going to add an oscillator that does what we described earlier, and a synthesizer. That also does what we described earlier. So that's it. It's not going to be a super duper complex one today. So first of all, we're going to write our basic ball class. It's going to move around and bounce off the edges, and we've done stuff like this before. But nonetheless, we know that we've got to do a few things to make that happen. create a class file, add a constructor, add a move method, bounce method, and display method. So let's do this step by step. Create the class file. Goodness me, we've done this a few times, it feels like. I like to create new files by right-clicking on my JS folder and going to New File. I'm going to call it ball.js, capital B, because it's a class. And as soon as I create it, I'm going to add in my very, very basic class structure there, class ball. And then, as always, we must remember when we add a new file, a new JavaScript file to our project, we always go to index.html and we add a script tag for it. I usually do that, as you just saw, by duplicating the existing script tag for the main script and then just renaming the file that it includes. So we end up with a script tag that includes ball.js, and we put that before the script. So that's done. What is next? Add a constructor. So let's read this. For now we want a constructor ball that can move around on the screen. So we need position, velocity, and speed. Those are things that it needs to know how to do. And it makes sense, as it so often does, to set its position via parameters, especially because we're looking ahead and thinking that we're going to, when we create a new ball, we're going to start it at the position of a mouse click. So we want to be able to specify when we create that ball where it should go at the mouse location. And we're also going to have a randomized fill property just so that the balls look a bit different as they move around. So, step 1, define a constructor method with two parameters, x and y. Let's do it. Constructor, that's how we write that, x and y. Simple as that. That's our constructor. Signature, they call that a function signature or a method signature. Set position properties via the parameters. Okay, well we've done that a lot as well. We know that we can create properties by saying this dot and then the name of the property, x, and I'm assigning the x parameter to that, and I'll do the same thing for y. Set position properties by the parameters. Sorry, I'm already not highlighting the right thing. Set a size property to a size you like. I mean, this is just kind of aesthetics to some extent. I'm going to use the 50 that I suggested in the steps. So we've got a size. Set a fill property that contains an object with random R, G, and B properties. Maybe set them to something like 200 to 255, a random number. Okay, so we're going to have a property called fill, and that is going to be set to an object. And inside that object, we're going to have an R property for red, and that's going to be a random number between, what did I say? 200 and 255. And then the same thing for G, random 200, goodness me, 200, 255, and, oh God, hope you don't program like I do. B, random 200, 255. Okay, there's our fill. So every time a ball is constructed, it gets a random R, G, and B value for its fill color. Set a speed property to a movement speed you like. Well, who knows what we like, but I've suggested 3 apparently. So this dot speed is 3. I'm just going to go with exactly what I told myself to go with in the instructions. Finally, set velocity properties to random numbers in the range negative speed to positive speed. That's so that when I create one of these balls, it just starts moving in a random direction. I'm just trying to keep it simple so that we don't have to control too much and write too much code. So the x velocity is going to be a random number between negative this dot speed and positive this dot speed. It's worth mentioning here that I can do this only because I just already defined what this dot speed is, right? I couldn't do these in the other, I can do this. I couldn't do these in the other order, right? I can't define Vx there relying on speed because I haven't defined what speed is yet. I have to wait until speed exists. Yeah, and same thing here for Vy. This dot speed, negative this dot speed to this dot speed, sped. So that's my constructor. That is all of the things that this ball needs to know for now. We're going to change some stuff a bit later. Add a move method, do the usual thing of adding the velocity to the position. I'm having faith that we kind of remember this basic physics equation where we add the x velocity to the x position and the y velocity to the y position. So let's add a move method like that. And then we say this dot x, I'm going to use plus equals this dot vx. So add the vx value onto the x value. And same thing for y. Okay, that's our move method. Every time we move, we change our position by our velocity. Add a bounce method. So this is going to require a bit more effort. Let's see. So first of all, I didn't even mention it here, it seems, but obviously we need a method called bounce, or this is not going to make sense. And what do we do inside this method? Well, we need to check if the ball should bounce off the walls, so to speak, of the canvas, the edges, and we should check horizontally and vertically, and if it does bounce, we should reverse the appropriate velocity. So step one, check if the ball has moved past the left or right edge of the canvas based on its x position, and if so, reverse its x velocity, step 2. Okay, so if the x position of our ball, this dot x, is less than 0, it's moved off the left-hand side, or if its x position is greater than the width, it's moved off the right-hand side, then set its x velocity to the negative of itself, i.e. reverse it. And then we can do the same idea for y, right? If the y position is less than 0, it's gone off the top, or the y position is greater than the height, it's gone off the bottom, then reverse the y velocity by making it the negative of itself. Good, that's how you bounce. That is the nature of bouncing. As I mentioned down here, if you want the bouncing to look a bit nicer, you should take account of the ball's size, because currently the way that it's bouncing is based only on this dot x and this dot y, and those are in the center of our ball, so it would bounce kind of off of its center. Really what we could check if we wanted to bounce off the edge is, rather than checking the middle when we're checking if it's bouncing off the left, we should check the middle minus the size over 2, and that will give us the left edge. And likewise, we should check the right edge here, so we would add this dot size over 2 here. And likewise down here, minus this dot size over 2 for checking the top of the ball, and plus this dot size over 2 for checking the bottom of the ball. That will just lead to slightly more authentic looking bouncing. It's not necessary. It's just an aesthetic thing. Okay, add a display method. Display the circle, well that should say ball, as a circle on the canvas. Use its fill property. Gosh, I'm being very terse, aren't I? Because I have faith that we know how to do these things. So if we are doing that, we want a display method. Whenever we display stuff, we should probably push and pop around it. Let's set no stroke, and we set the fill. What do we set the fill to? Well, we have a fill property up here, so we should use that. And we do that by saying fill. What's the red? It's this.fill.r, because r is inside the fill property, and likewise for the others, this.fill.g and this.fill.b. And that will give it our random color. But we should probably actually display it, so we draw an ellipse at this.x and this.y, the position, and with a size of this.size. Hey presto, we have a circle that can be displayed at its position. And I believe, yeah, that's it. So that's our class. It's a relatively simple thing, but I mean also kind of like beautiful and complex as well. Like, you know, this is proper programming. We've written the code that will make a circle move around on the screen randomly with a random color and bounce off the edges. That is not nothing. I don't want to downplay it and say that it's just simple code. We have done this sort of thing multiple times before, but it's still pretty incredible to be able to write a program that does this. So pat, pat, pat on the old back for that one. Not being sarcastic, I mean that. Okay, part 2. Integrate the class into the main script. Currently it's pretty dissatisfying because our program as yet does nothing. If I run it, for example, by going to Atom Live Server, which is up there, and starting it, we get squarely nothing because our main script doesn't yet create any of these walls, nor even create a canvas or set it to a background color. So nothing going on yet. So let's do the integration step. So what do we want to do? We want to be able to click to add balls to the canvas. And in order to kind of implement that kind of idea, we're going to need an array that is going to store those balls. As we click, we should add them into the array. And then we need to move and display and bounce all of the balls in the array and draw so that we see them and they behave in the way that a ball behaves. So again, we've seen this kind of thing before, but let's go step by step. Add an empty array called balls to the top of your script. Okay, so we're talking about the main script now, right? Over here. So the balls is going to be let balls is assigned empty array is just empty square brackets like that. So that's where they're going to go, but at the beginning of the program there is nothing in there, empty. In setup, create a canvas with your preferred dimensions. Very classy. So let's do that. Create a canvas. Up to you what your dimensions are. These days I'm a 600 by 600 guy. Having done something here, I guess I'll edit this comment. I'm trying to be a good person. Just creates the canvas. In this case, it's a pretty simple setup function. Doesn't really do very much. And that's partly because I'm not creating any of, for example, creating any of the balls at the beginning. They're all added on mouse click, so there's not a lot for setup to actually do. In draw, I feel like this should be indented. Set the background. Always a good thing to do in draw. You know how much I like a black background. I'm not going to deny you yet another black background here. Okay, write a for loop that goes through the balls array, and for each element in that array, call move, bounce, and display. Okay, fair enough. So it's the standard for loop that goes through an array. We've seen it quite a few times. It's a for loop, so we write for, and then in its parentheses, we start I at 0. We count up to the length of the array, which is balls.length, and we go up by 1 each time. That's how it works every single time. I have this habit of creating a temporary variable where I get the current element out of the array, balls at position I, and put it into my variable ball. Just I find that adds clarity. And then let's do the things that a ball can do. Ball.move, we'll move it by its velocity. Banal, I've written a few times. Ball.bounce, we'll bounce it off the edges of the canvas. Ball.display, we'll display it on the canvas. And it will do that for as many balls as are in the array. When the program starts, that is going to be 0, so it's going to not do anything because there's no balls to do anything with. As we add them, the array will get longer, balls.length will get longer, and we'll do stuff to all of the things in the array. Perfect. We're being fancy, so we're going to define a create, got turned Australian for a second there. Define a create ball XY function, and in it, create a new ball object at the specified location, the X and Y mentioned here, and store it in a variable, and then add that new object to the balls array with push. Okay. So those are our 3 steps that we're going to do right now. So we're going to define a new function, create ball at a specified position. What do? We're going to create a new ball, let ball. Again, it's a temporary variable. It's got the same name as this one. That's fine. Temporary variables are like that. We know it's temporary because we're using let inside some curly brackets, and this variable will only exist while it's inside these curly brackets. So we can use the same name elsewhere. And we're going to create a new ball, calling the constructor of the ball class, and we're going to just give it whatever the X and the Y are that create ball was passed. And then we're going to return, are we going to return that ball? No, sorry, we're going to add the ball to the balls array. So we're going to say balls array is balls, push the new ball that we just added, like that. I think that's what I told myself to do. So every time create ball gets called, a new ball is added to the array, and will then be kind of processed by the game. Finally, steps 9 and 10, which should actually, again, be indented. I feel weird about that. Define a mouse pressed function, the one that automatically gets called by P5 when the mouse is pressed down, and in it, call the create ball function, passing the current mouse position as arguments. Because this mouse press is going to call this create ball function, I'm going to define the mouse pressed above it. That's sort of traditional, that you, when a method calls, when a function calls another function, the one it calls is below it. So mouse pressed is the default name there, and we're just going to call create ball, which is our function, with mouse X and mouse Y as the position to create the ball at. And that is a nice, tidy looking script right there. It's good to create this create ball function like this, just because we might want to do it in other contexts. And this way we kind of abstract it. We keep it separate from just always being done with mouse pressed. So, moment of truth, we've written quite a large amount of code to get to this point. We should now be able to click on the canvas, and when we do, we see a ball appear, it should move, and it should bounce. Will that be the case? Let's find out. Feeling scared. Oh, there's the canvas. That's a good start. And if I click, ah, 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 it's alive. It's already very satisfying. It's had lots of them. I'm clicking a lot. Oh, it's starting to look like a kind of particle simulator. That's basically what it is in some sense. Okay, well, that worked. So we've got our basic kind of physicsy setup, right? And then the remaining thing that I wanted to do is just kind of add sound to this using P5 sound classes, the oscillator and the synthesizer, just because that's a fun thing to do, and it's nice to kind of connect those sound making classes with something to do with physics, just to see it happen and realize that it's a thing that we can do. Okay, back we go. Add an oscillator to the ball class. So we've got our core simulation running. Let's integrate audio. So the first idea was that as a ball moves around, it should play a tone based on its distance from the center of the canvas. That's pretty arbitrary, and you can do all kinds of other things. But this is just, at least it's a rule that we can follow. So the steps are, we need to add an actual oscillator object as a property of the ball in the constructor. We need to change its frequency as the ball moves. And since we're using audio, it is only polite to add a user start audio to the main script. Almost forgot to do that. Okay, add an oscillator. So in the constructor, we're going to create an oscillator as a property of the ball, and we're going to need a couple of extra properties. The minimum and maximum frequency range, because it's going to be changing frequency, so we need to know the lowest and highest frequencies that it should use. And we should start the oscillator in the constructor and probably turn its amplitude down a bit, because as you may now know, oscillators can feel kind of unpleasantly loud in your ears. So thing one, add an oscillator property to the constructor and assign it a new P5 oscillator object. Okay. So back to the ball class, back to the constructor. So we've done all the basic kind of physics and display stuff. Let's add in our oscillator section over here. I'm being a bit patchy with my commenting, but I'm just sort of occasionally marking out what I'm doing. So this dot oscillator is going to be my property, and I'm going to assign it a new P5 oscillator object, just like that. I'm not going to pass it a wave type or a frequency, because it's going to change frequency anyway, and I'm happy with the default sine waveform. I think that sounds the least jarring anyway. Okay, so that creates the oscillator. Add near frequency and far frequency, or FREQ, properties that will determine the frequency when the oscillator is near to the center of the canvas or far from it, maybe 220 and 440 question mark. You could also randomize this. There's a lot that we could do. I'm just going to keep it vanilla. So two more properties. This dot near frequency, when it's close to the center of the canvas, I'm going to make that the 220. And far frequency, when it's far from the center of the canvas, 440. Again, there's many possibilities there. This is just some almost placeholder numbers. Set the amplitude of the oscillator to something a bit quiet, maybe 0.1. Use the amp method. So when we want to tell our oscillator to calm down a bit and not be so loud, we can use the amp method, this.oscillator.amp, and set it to just something a bit quiet, like 0.1, so it's not going to deafen us when it starts making its noise. Start the oscillator, use the start method. Yeah. So this dot oscillator dot start, we want to start it in the constructor, because that's the moment that the ball will really start existing, so it may as well start its droning sound immediately. Okay, that's the constructor. So if we were to start the program now, I hope that the ball objects would make their tone, right? It would be at the default frequency, which I think is 440 hertz sine wave. But we should still hear something. Let's see. Let's see if that's the case. Maybe it won't be the case. And then we can feel sad. Oh, there you go. So I added it. It's making it sound. As I add more, it kind of gets louder, especially if I add it. Oh, God, that's quite unpleasant. Especially if I add it so that the sine waves are lined up. If you imagine the actual waveforms, then their peaks are lined up, and then they are louder because there's more amplitude, because it's additive. Okay, there you go. I wonder if that means that I could actually cancel it out if I added them. Doesn't matter. Okay, ignore me. So we've got sound. They make a sound. It's a very boring sound because it's not based on anything to do with what they're doing. They just make a 440 hertz tone. And what we want to do is change the frequency in move. So what are we going to do? In the move function, we want to determine the actual frequency it uses by its proximity to the center of the canvas. So let's do this. The first thing we need to do is calculate the distance between the ball and the center of the canvas in move. That's easy. We know how to use the distance function for that. So in the move function, maybe after this, let's say update frequency is what we're going to do here. Frequency. First of all, calculate the distance to the center of the canvas. So we'll just call this one, should we call this one D? Yeah. The distance between this dot x and this dot y, the position of this ball, and width over 2, height over 2, the center of the canvas. So that's the first distance that we care about. How far away is the ball from the middle? Calculate the maximum distance between the ball, sorry, I was all confused by my own instructions. Calculate the maximum, should bold that or something, distance between the ball and the center of the canvas. What is the furthest that the ball can be from the center? We know that the minimum it can be is 0 when it's in the center. What's the furthest it can be? Well, it's the diagonal from the center of the canvas to one of the corners, right? So we could either do this by doing good old Pythagoras, right? Like do the sum of the square of the two sides of the square of the hypotenuse kind of thing. Or we could figure that it's the same as the distance from, for example, 0, 0, the top left corner, and the center. That's the length of the diagonal. So we can calculate it with just using dist, basically. So let max dist, let's be fancy and abbreviate, equal the distance from 0, 0, the top left corner, to the center, width over 2, height over 2. Dist, in the background, all that dist is doing is Pythagoras anyway, so that's just, it's literally what it does. It's nice not to have to do it ourselves. So we've got the actual distance and the maximum distance. That's good because now, along with 0, we know the range that that distance can possibly be in. And that means we can do a map. So create a new frequency variable and assign it to the map of the distance from the ball to the center of the canvas, which has a range 0 to the maximum that we just calculated, and we map it to the near frequency, far frequency properties. So let's do this. So the new frequency, I'm realizing I've left something rather important out there, but I'll get to that in a second. Let the new frequency variable be assigned to, so I want to map. What do I want to map? I want to map the D variable, the distance that this ball is currently from the center. I know that that is going to be between 0, when it's right in the center, and maximum distance, when it's as far as possible away from the center. And I want to map that to the frequency range that I came up with here, near frequency and far frequency. So when it's closer to 0, then I want to use the near frequency, near fric, and when it's closer to the maximum distance, I want to use far fric, far frequency. So that is the frequency I want to use. If we look at the instructions as they are appearing on my screen right now before I fix them, you will notice that I haven't actually said that we should set the frequency of the oscillator, which we should do. So this .oscillator .frec is the method for setting frequencies, and we're going to set it to new frequency, like that. New frec, just like the old frec, but better. If we don't do that, then none of this calculation was worthwhile, right? Because we have to set the frequency in order to actually hear a difference. I could go and test it now, but just to like be polite, because we're using audio, let's put user start audio in setup. It doesn't actually make that much difference, TBH, but why not do it anyway to be a good person? User start audio. Okay, so unless I'm mistaken, we should now have the ball's shifting frequency based on their proximity to the center of the canvas. All going to plan. So let's add one. If I add it near the middle, we should hear it playing the near frequency, right? Because it's going to be near to the middle, and as it moves away from the middle, we'll hear it get higher in frequency. That's pretty satisfying. Getting a bit closer again, and it's getting further away at a certain point. Goes up again. Lovely. And the more of these I add, and because they're moving at random speeds, we get different variations. play something spooky. I'm a little surprised by how spooky that is. But you could hear it works, right? Like when it's near the middle, it's a lower sound, and as it moves towards the edges, it's higher. Perfect, and this is like cool because it's the dynamics of an oscillator, which knows how to make a tone at a particular frequency, and the physics that is controlling how this ball moves. So pretty good. Okay, let's do part 4, the final part actually. Add a synthesizer to the ball class. So the second flourish that we're going to have is every time a ball bounces, is going to play a note. And we're going to get it to play a note from a specific musical scale, so that as the different balls bounce in different places, they're kind of playing musical notes, and it sounds beautiful and amazing, and we get awarded the Nobel Peace Prize for music if that exists. So there's various things that we're going to need to do, and let's look at them. So the constructor of our ball is going to need a property representing what note the ball plays, and it's going to need a synthesizer to actually play the note. In bounce, when we detect that a ball is going to bounce, we should play the note that the ball is meant to play, and then we're also going to need to actually change our setup of things in the main script so that when we create a ball, we tell it which note that ball should play whenever it bounces. I think that makes sense. Let's do it step by step. So add a note and the synthesizer to the ball constructor. For each ball, we have to have a synthesizer object that can play a note and the note that it should play. So the note part has two parts, right? Because we need, when we create a ball, we're going to specify the note, so it needs to be a parameter in the constructor, and we need to store that in a property. So let's go back to the ball thing, and we're gonna have whatever note it is that this ball is going to play. It's going to be specified when we create the ball, so it's a parameter of the constructor. Where should we put this? Let's put it down here in a kind of synth section of our constructor. So this dot note is going to be the property that tells you which note to play, and I'm going to put in whatever is in the note parameter. Tick. Add a synth property and assign it a new P5 polysynth object. Polysynth sounds a little bit like something you would buy at Home Depot. So this dot synth is my synth property, and I'm going to assign it a new P5 polysynth object. Again, there are things that you can set in the polysynth constructor. It was the maximum number of voices and the voice to use from memory, but we can just use the defaults. It's completely fine. So now my ball, when it gets created, will be told what note it plays, and it's going to have a synthesizer object that it can use to play the note. Good. Play the note in bounce when appropriate. So if the ball bounces, we need to play the note. To keep things kind of separated out in case we want to play notes in other contexts, let's define a play note method that plays the ball's note using its synthesizer. We need to remember how the play method in the synthesizer works. Importantly, we provide it with the note to play, the velocity to play it at, which is how hard you hit it, the delay, which we clearly don't want to delay, I don't think, when we're bouncing, and a sustain. I'm suggesting here apparently 0.2, 0, and 0.1 for those velocity, delay, and sustain. So let's go down to bounce, and after bounce, because we know that bounce is going to call this method, let's say play note is our method, and what do? We say this.synth.play, that's the method for playing notes. What note do we want to play? Do we want to play like C4? No, we want to play the note inside the note property. So this.note is how this ball knows which note to play. And then velocity, what have I suggested? I've already forgotten. 0.2, so hitting it quite gently. The reason I'm thinking ahead of making this a lower number is just as there's going to be quite a few of these balls potentially bouncing around, we don't want them to be super loud because it might get quite obnoxious. But you never know, maybe we'll make it louder. I'm going to have a delay of 0 because I want these notes to play immediately when the bounce takes place. I don't want to wait. And what sustain, I think I suggested 0.1, so they're kind of like a bit perky, a bit short and perky. So play note does this. It plays a synthesizer note. In bounce, call play note if the ball bounces. Don't forget to use this when calling the method. Indeed. So we know that inside these if statements, when we're reversing velocities, that's when we should play the note. I say don't forget this because it's easy to accidentally write this, right? And think, oh, well, there you go. It's play note. That's what it's called here. So that's how I should call it. we need to always remember that if we're inside a class, which we are, right? Class ball up the top here. If we're inside a class and we're calling another method of the class inside, we always say this first. So this.playNote specifies this particular method here. And that is part of the same class. Same thing when it bounces on the Y, this.playNote. And that is all the modifications that we need for the ball. We are, if you can believe it, almost there. Still, we haven't really made anything happen. The reason being that although we do call play note and we do tell the synth to play a note in the ball class when it bounces, because we haven't yet specified the note when we create the balls, there's no way for it to know what to do. So we need to do that next. And we're going to use a scale of notes in an array so that we can choose kind of musically compatible notes. So let's do each of these steps. Add a notes variable to the top of the program and assign an array containing a scale of notes. Each note should be in a string. For example, F minor is, this is actually incorrect, so I will correct this and I will type it incorrectly now. We go F, G, A flat, B flat, C, D, E flat, and then F again, an octave higher. So let's do that. So what we're wanting is an array up here. I'm going to represent F minor just because I have the reference to it. You could look up a different scale. You could use a major scale if you wanted this to sound a bit less spooky and a bit more happy. And I'm going to have an array of notes that's going to represent the F minor scale inside my array. And this time I'm going to just write them in. So the first note is an F. Now I'm going to start this at F3 because that was the mistake that I have in my notes there. The next one is a G note, so that's G3, F and then G, right? But then when we go to A flat, because the notes wrap around at A, we're going to be at A flat 4. That's why I made it F3 and G3, not F4 and G4 as I have here. Then B flat, I see from the list there. So B flat 4, C, C4, that's the next one. C4 is also an explosive, but in this instance it is just middle C. D flat 4, D flat 4, E flat 4, E flat 4, and then we get up to F. And in this instance it's actually going to be F4. That's just a horrible mess that I made in the instructions there, and I apologize. So that is my F minor scale. F, G, A flat, B flat, C, D flat, E flat, and then F again. Beautiful. So what am I going to do? When I create each individual ball, I'm going to assign them a random note from this array so that they can play notes from that scale. Let's go. In the create ball method, choose a random, literally just what I said, choose a random note from the notes array and pass it as an argument to the ball's constructor when it is created. Because we know in the ball now, when in the constructor, after the X and the Y, you're supposed to tell it what note to play so that it can tell the synthesizer to play that note. So down below in create ball, when we create a ball, we need a note argument there. So we're going to say our note, I'm going to put it into a variable first, is going to be a random element from the notes array. It's going to be one of the notes from F minor. And sorry, when I create the ball, I'm going to pass it that note as well. So when I create any ball, it's going to be at a specific position, X and Y, and it's going to be using a random note from the notes array. And that, as they say, is that, assuming that it works. Let's add a ball. Add it in the center for excitement. Okay, there you go. You heard it bounce. Same note. Oh, there we go. That one's got a different note. Let's add a few more. You know what? The droning is too damn loud. Let's turn it down a little bit. This is anticlimactic because that was meant to be the end, the end of the exercise. But I found that too irritating. I'm just going to turn the amplitude on the oscillator down a bit so I can hear the beauty of the synthesizer a little bit better. And in fact, let me turn the synthesizer up a little bit by setting its velocity to a higher number there. I happen to know that it's the second argument. really these things should probably be properties of the ball as well. Let's listen to it now. Ah, it's better. Oh yeah. Oh yeah. It's playing music with physics. Now it's playing the blues. Okay, I could listen to that for a while. So that's the activity. I find it amazing that we can combine physics and music generation like that, and get something out at the end that is kind of amazing. Like, it's the sound of physics, in a very real sense, in a very real and very mathematical sense. So I think that that's quite spectacular. So hopefully you enjoyed that as well. If nothing else, it's an example of integrating these kinds of dynamic sound generation things into a program that's doing something else. So it's not like you have to make a music program. You can incorporate them in other sorts of ways. There's lots of other stuff that you could do to make this a more interesting physics simulation. Maybe the balls can bounce off of each other and they could play like combined notes or chords when they touch each other. We could add ways for the user to delete balls or drag balls and throw them, maybe to change how they sound. Maybe the velocity that we play the note at is related to the velocity that the ball bounces into something at. If we wanted to get more technical, there's all kinds of stuff that you could do, and that's kind of the point. Is it's once you start building up even a simple idea, there's all of this cool stuff. You know this, but there's all of this cool stuff that you could then potentially do. So that's it from me. That's the sound activity. I didn't make too many mistakes, and I hope you enjoyed that project. I'm kind of pleased with how it turned out. So that's it from me. I'll see you in the next video if there is one. Bye.